Alright guys, it's Mr. Lynch coming back at you with another great math video. So today, lesson 4.2b, substitution method for solving systems of equations. So we're going to go more over substitution. Just to refresh ourselves on what substitution is, what we're going to do is we're going to solve this first system here. So we know that a square is worth 2 circles. So let's plug that in for each of these squares. So we're going to go circle plus 2 circles plus 2 circles equals 30. Well, 5 circles equaling 30, we're just going to divide by 5, and we get that 1 circle is just 6. So a circle is worth 6, which means that a square is equal to 6 plus 6, which means a square is worth 12. Now let's look up here. Ooh, man, let's solve this for circles. Sure. So a circle is worth 12 minus 3 triangles. So if we plug that in for each of our circles, we're going to get 4 triangles. I'm just going to write out the numbers. I'm not actually drawing all this out. That's ridiculous. That's so much. 4 triangles plus 12 minus 3 triangles plus 12 minus 3 triangles plus 12 minus 3 triangles is 26. Okay, so now I've got 36 plus 4 triangles minus 9 triangles equals 26, which means I have 36 minus 5 triangles equals 26. Let's move this 5 triangles to the other side and this 26 to the other side. We get 10 equals 5 triangles, which means a triangle is worth 2. Which means if a triangle is worth 2, then a circle is worth 12 minus 6, which means a circle is 6. Does that math add up? That math does add up. We're perfect. So let's build out the system of equations here that goes along with this. Let's give triangle to x. So we're going to say 3x, which means circle is y, clearly. 3x plus y equals 12. And then down here we have 4x plus 3y equals 26. So now what we did there is we solved this top one for y. So we said y was equal to negative 3x plus 12. Then what we did is we took this negative 3x plus 12, plugged it in right here for y, and we got 4x minus 9x plus 36 equals 26. And we solved that. So really, the shapes are just kind of a thing to get you guys going. It's really not something that we're going to keep using, but it's something that we're using to show you guys what's happening. Now, these are honestly some kind of confusing steps. So bear with me and we'll just explain it a little bit easier, okay? So rewrite one of the equations so that one variable is expressed in terms of the other. We're going to solve for one variable, guys. We're going to say one of those variables is equal to something. Then we're going to substitute that. So we're going to take in this part here, whatever that variable is equal to, and plug it into the other equation wherever we see the variable we solved for. Then, once we solve that for what variable's left, we plug that back in to one of the equations. Does that make sense, guys? We already did that. Let's look at this one. All right, so to rewrite this, let's go squares equal x, circles are y. So we get 2x plus 7 equals y, and 3x plus 2y equals 35. Well, would you look at that? Step 1's already done for us. We've solved for y. We know what y is in terms of x. Y is just 2x plus 7. So, wherever I see a y in the other equation, I'm going to put 2x plus 7 there. So in order to do that, I'm going to go 3x plus 2 times 2x plus 7 equals 35. Now, we're just going to use our 5 steps. Step 1, distribute. All right, let's distribute this 2 through. So we get 3x plus 4x plus 14 equals 35. Step 2, combine like terms. Well, we have a 3x and a 4x, so let's add those together to get 7x. So we get 7x plus 14 equals 35. Step 3 is to move our variables. We don't need to move a variable because we only have it on one side. Step 4, move our constants. Let's move this 14 by subtracting 14. So we get 7x equals 21. Step 5, divide. And we get x equals 3. So now that we know what x is equal to, we're going to take this and plug it into 2x plus 7. So we get 2 times 3 plus 7 equals y. 2 times 3 is 6. 6 plus 7 is 13, which means y equals 13 and x equals 3. Now I want you guys to check the solution to see if it works. Alright? Double check that it works. Alright, let's build one more system. So these are going to be my x's and triangles are going to be my y's. So 3x plus 1 equals y and 2x plus 3 equals y. Well, would you look at that? They're both equal to y, which means I'm just going to end up setting them equal to each other. Because if I plug this, whichever one I plug in for y, I'm basically setting them equal to each other. Doesn't matter which one I plug in for which y. I'm just going to say, I got 2x plus 3 equals 3x plus 1. Step 1, distribute. Can we distribute here? No, there's nothing to distribute. Step 2 is we're going to combine our like terms. Well, we can't do that either because we don't have anything that's on the same side. Step 3 is to move our variable. And which variable are we going to move, guys? You got it right. We're going to move the 2x because it's smaller. So then we get 3 is equal to x plus 1. Now in step 4, I need to move my constant, which means I subtract the 1 so I can get the x by itself, which gives us 2 equals x. What I'm going to do here is I'm just going to plug in 2 for whichever x I choose. I'm going to go 3 times 2 plus 1 equals y. 6 plus 1 equals y. 7 is equal to y. I want you guys to double check that solution. Double check that 2, 7 is a solution to this system of equations. If it's not, that kind of sucks. That'd be bad. All right, let's jump down here to problem 7. So in these problems, we're going to use substitution to solve. So in some of these, we're also going to graph them as well. So here, we're given that y equals something for both of these, all right? Which means we're just going to set them equal to each other. 5x plus 4 equals negative 3x plus 12. We're going to add this 3x to both sides because it's the smallest variable. 8x plus 4 equals 12. Now to isolate that 8x, we're going to have to subtract 4. By subtracting 4, we get 8x equals 8. And now that we have 8x equals 8, we just need to divide. Divide both sides by 8, and we get x equals 1. Now, we're going to take this x value and plug it into one of these two equations. I'm going to choose the positive one because I like doing that. So, if x equals... Oh, I messed up. Wow, and you guys didn't even... Come on, guys. Come on. It's 8x plus 4 equals negative 12. You guys just let me do that, really? How could you? Okay, so now let's subtract the 4. We get 8x equals negative 16, which means x equals negative 2 when we divide both sides by 8. Now I'm going to take this negative 2 and I'm going to plug it in for x. So let's just choose the top one. Y equals 5 times negative 2 plus 4, which means that we get y equals negative 10 plus 4, y equals negative 6. Which means our solution is at the point negative 2, -6. Let's do this graphing one. Why not? So again, guys, what we're going to do is we're going to set these equal to each other. All right, so we get 6x plus 4 equals 6x minus 10. Ooh, we might run into an issue here. Let's just subtract 6x and see. Yeah, we ran into an issue. 4 is not equal to -10. So we have no solution here, guys. These are two parallel lines. I'll let you graph them. Let's do this graphing one right here. This will be easier. So now we're given x equals 2y minus 4. So where I see an x here, I'm plugging in 2y minus 4. So we get 2y minus 4 plus y equals 2. 2y plus y is 3y minus 4 equals 2. Let's get rid of this -4. So we're going to add 4 to both sides. 3y equals 6, which means y is equal to 2. 2, get it? Sorry. So, now I'm going to come back up to this original equation. Actually, I could really put it into any equation, but it's really easy when we have x equals something. All right, when our other variable is equal to something, we can just plug in our new variable that we learned and solve for that one really quickly. So we get x equals 2 times 2 minus 4. Well, then x equals 4 minus 4. Why are all the graphing ones boring? Why is x equal to 0? All right, let's see if this is actually the point. All right, so in slope-intercept form, our two equations are 2y equals x plus 4, y equals 1/2 x plus 2. This one here is y equals negative x plus 2. And as you can see, since they have the same y-intercept, they're going to intersect right at that point, 0, 2. So, hey, we solved it. Nice job, guys. Nice job. All right, let's get down here. Let's look at some of what they actually mean, because I want you guys to understand what these mean. So, Nettie's Bargain Clothing is having a huge sale. All shirts are $3 and all pants are $5 each. You go to the sale and you buy twice as many shirts as pants and you spend $66. So the following system of equations models this situation where S is the number of shirts and P is the number of pants. So in words, what does each of these equations in the system represent? Well, S equals 2P means you got twice as many shirts as pants. Twice as many shirts as pants. And then down here, the 3S plus 5P equals 66. That's how much you spent. All right, so now we're going to solve this system by substitution. Okay, so in order to do that, if we look up here, we have S equals 2P. So wherever I see an S, I'm going to plug in 2P. So I get 3 times 2P plus 5P equals 66. Well, then 6P plus 5P equals 66, which means 11P equals 66, which means P equals 11. And if P is equal to 11, then S is equal to 2 times 11, which means S equals 22. Does that make sense, guys? We bought 11 pants and 22 shirts. Honestly, those are some pretty good deals. Oh, but wait. Does that make sense? No, because I said P equals 11. What am I doing today? Why? P doesn't equal 11? You guys didn't catch me. It's P equals 6. 66 divided by 11 is 6. P equals 6. S equals 2 times 6, which means S equals 12. Does that one make more sense? I sure hope it does. It does. It works. Wow, it's been a long day. Wow. All right, guys. So that's really all I got for you today. I'll have you guys finish those out on your own. As always, guys, I hope you enjoy the math. Make sure you hit like, make sure you subscribe, make sure you are ringing that notification bell so you guys can see these videos as soon as they come out. As always, guys, we'll see you later.